One last time with the filling machines data. In filling machines version 3, I took filling machines version B and deleted the last observation. So you can see we've now only got 14 observations, not 15. The reason I wanted to show you this is that the output from the Bonferroni tests becomes a little bit different. We've got now an unbalanced design. When we've got an unbalanced design, there's no longer this guarantee that if means 1 and 2 are different from one another, and the mean of 2 is greater than the mean of 3, that the mean of 1 and 3 will be different from one another. So let's see how this shows up in our output. We're going to see a similar F statistic because it still looks like filling machine A has a higher mean than filling machines B and C. Still a significant test, so we're still less than 5%. We're at about 0.6% now. Scroll down to our Bonferroni output, and we've got a different looking piece of output now. The way to read this is to look at the specific comparisons being done over here. So we're comparing machines A and C, A and B, C and A, C and B, B and A, B and C. Over on the right, we've got our significance. So 3 stars here tells us that these comparisons are significant at the 5% level. So A and C are significantly different at the 5% level. By symmetry, C and A are different at the 5% level as well. A and B are significantly different at the 5% level. By symmetry, of course, B and A are significantly different at the 5% level. But machines B and C are not significantly different from one another. So when we've got an unbalanced design, we're going to get output that looks like this. It's going to take us a little bit longer to interpret it than the graphical output that we saw previously, but we can get the same information.